Guys, let's think about what we know, because we've already solved some polynomials, right? What were those some polynomials that we factored and solved? Starts with a Q. Quadratics. We spent a whole chapter on quadratics, okay? So now we've got these polynomials that are going to factor differently. So we've got sum and difference of two cubes. We've got grouping.
That's what we were just talking about.
All right. So tell me if you had something like x squared plus 5x equals -6. How would you go about solving that?
Get that on the other side.
You got to get it on the other side because it's got to equal what before you start? Anytime before you start, it's got to equal 0. So I would go ahead and get it on the other side. And then what would I do?
Check for your purpose square, try to factor it.
I try to factor it. I go through all my steps. Step 1, does it have a GCF? Step 2, is it a special pattern? No. Step 3, can I put it in the box?
Yes.
Yes. This is easy because it has a leading coefficient of 1. What multiplies to 6 but adds to 5? 3 and 2. Now, I get x2, x3.
Wait, so what tells you you can't put it in the box?
That quadratic form, even, half, constant.
What's it constant?
No variable hooked to it.
Wait, so if it's like that, then you can't do it in the box?
Correct. All right, x plus 2, x plus 3. And this is, I'm moving a little fast through here because this is chapter 1 kind of recap right here, right? Okay, so then I get x plus 2 equals 0 because this is the what property? But what's the property that lets us set each piece to 0 when I'm multiplying? Y'all remember? You might not know the name. You might not remember the name.
What's the first letter?
Z. 0 product property. Good job. 0 product property lets us split up when we're multiplying and set each piece to 0. Okay. So the process is going to be exactly the same, but now my factoring is a little more complicated. And you're also going to have to go back and pull from things in your brain like imaginary numbers, simplifying radicals, how to solve a quadratic that's not factorable. What would you do? What do you do if you have a quadratic you need to solve that is not factorable? You got to solve it though. Quadratic formula.
Go touch.
Good job, good job. All right. So we got to pull all this prior knowledge to solve these, okay? So let me show you an example. Remember, before we start, we always need to make sure it equals what?
0.
0. Also is helpful if you make sure it's in standard form before you start too. All right, so looking at this one as an example. What do I need to do first?
Get 18 on the other side.
No. You gotta do the other two because you can't have your first number. Well, no. Yeah, you can.
Which one do I need to move? What do I need to move?
I don't know.
18.
Wait.
You can simplify. A's got to be positive.
Because, yeah, you gotta have the A
A's
positive.
got to be, sorry, y'all. A's got to be positive. So I need to move the 18.
That's what I said.
And I'm actually going to put it here.
And then take away 3x.
Oh, then you can get quadratic form if you take
GCF, does it have one? Because that's my first step is GCF every single time.
You thought, Grace.
3x.
What?
What's left?
8 negative x squared. What?
Taking a 3 out and an x.
I thought we were on the next one.
Plus 5. And Drew said, yes, if we take that out, we're going to have a quadratic form, and we absolutely do. Right, Ben? Even, half, constant? Mm-hmm. And quadratic form is handy because I can do what? Put it in the box. Same signs.
Wait, I thought you said if it's like that, you can't put it in the box.
Yeah, that's what I heard, Ben.
Yeah.
I heard
Can.
quadratic form equals can.
No, I just heard like the
No, it was always
double,
can. No, it's
half, constant equals no box.
No equals box. Anything else can.
Wait, so what? But we just did that last one that wasn't like that.
That smells bad.
I'm sorry.
It was like an airport in here.
It smells like somebody flying here.
Why is that?
Yeah.
All right.
Okay, wait, I have a question.
Because 5's not a perfect square, so it has to
Every
be,
one of these problems
both of them have to be perfect square. Not necessarily. Yeah.
Okay, so why did you pick the x squared minus 1 to make it the 2?
Because that's perfect. Those are both perfect squares.
Oh.
5 is not a perfect square, so it doesn't break down. So 1 is always. Yes, Ben.
I could have sworn the thing we just did was not like the plus then the half and the constant, but we still did the box.
You want me to go back and show you?
Yeah. It was that one.
Even, half, constant.
I just didn't see the second test.
All right, so now the reason that I do all this is because I need pieces being multiplied together so that I can set them equal to 0, so that I can solve them, so that I can find all 5 solutions, okay? So I have 3x equals 0, x minus 1 equals 0, x plus 1 equals 0. Guys, if y'all could stop. X squared minus 5 equals 0. So now I'm going to solve each one of those. Okay? Divide by 3. X equals 0 is one solution. And remember, by solutions, I'm talking about if I graph these things, which we are getting ready to do on our calculators, these are x-intercepts. These are places where they cross the x-axis. Okay? X equals 1. X equals negative 1. And x equals, 1, 2, 3. 4, 5. There's your plus minus. Add 5 and take the square root here. Add 5 and then take the square root. 1, 2, 3, 4, 5.
How many parabolas is this?
Plus or minus means positive root 5, negative root 5. These are no longer parabolas. Look at your biggest exponent that you start with, and that's an indication of how many solutions. The only problem with that is that sometimes you'll have what we call repeated solutions. So when you factor, like you might get x plus 2, x plus 2. Well, that's both negative 2, but that counts as 2 solutions with it. 7 solutions, correct. All right. Equals 0. So I need to jump straight into factoring. 4x. What's left? x4.
10x squared 39.
Oh, I didn't mean to pick one just like the last one. That's okay. That's quadratic form. So right off the bat, I know I can go ahead and put it in the box. Even, half, constant. Right? All right. X to the 4th, 9. What multiplies to 9? Ask 10. 1 and 9. So I got 9x squared, 1x squared. What's the GCF here? Bless you. X squared. How about here? 1. How about here? And here. Both signs are minus, so I've got 4x, x squared minus 1, x squared minus 9, and what do you notice?
What? The perfect.
They're both difference of 2 squares. But how many solutions should I have? Look back at the 5. Nope. All right, so x minus 1, x plus 1, x minus 3, x plus 3. Now everybody goes to 0. 4x equals 0. X minus 1 equals 0. X plus 1 equals 0. X plus 3 equals 0.
Why can't you just cancel them out? Like, back and
What you mean?
Like x minus 1 and x plus 1 is 0. So couldn't you just like cancel them out?
They don't cancel though. Yeah, you can't cancel them like that. Plus or minus 3, plus or minus 1, and 0. You could theoretically at this point set each piece to 0. You add 1 and take the square root, you get plus or minus 1. If you add 9 and take the square root, you get plus or minus 3. Let's do one that's a little bit harder.
How do you know it's like you're supposed to break it up so many times?
You keep breaking until you can't break anymore.
Well, how do you break the first time? Like, what were you saying about the minus square or whatever?
It's, you talking about the quadratic form?
You know, I know how to do
Even,
that part.
half, constant.
I know how to do that part, but then what do you do once you get the answer in the box? Like
Here?
the first one.
Here.
Yeah.
You check each parenthesis and you go through everything again. This one, is it a special pattern? Can I put it in the box? Is it a special pattern? Can I put it in the box? Special pattern because it's different than 2 squares.
What is the pattern?
They're both perfect squares with a minus in the middle.
Okay.
That's number 1 on your sheet. All right, let's do another one. This one's gonna be a little harder. What do I move where and why?
You're gonna move
No.
the -6 to the beginning.
Why?
Yeah.
So it can be positive.
You want leading coefficient positive. I look at it, I know that 4 is my biggest exponent that I see, right? So I'm going to move it over and keep it positive. So I get 6x4 minus 27x cubed plus 15x squared. Now I go through my process. GCF? 3x squared. This one's going to have that repeated solution I was talking about before, so even though we should get 4 answers, one of them is going to be the same thing twice. What's left? 2x squared minus 9x plus 5. Look at what's in parentheses. Okay, so put it in the box, same signs, multiplies to 10, adds to 9. You're right. It won't. I don't think you meant to be right, but you are right.
Wait, so it won't work in the box?
It won't factor. It's a CBF. Which means, so look, if 3x squared equals 0, and 2x squared minus 9x plus 5 equals 0. If I can't factor it, I have a whole toolbox full of references from chapter 1 that can help me solve a quadratic that cannot be factored. I can complete the square, yeah.
Why can't you factor it?
If you put it in the
It
box,
gets 10x squared, and then couldn't you use it?
but the signs have to be the
Negative
same.
1. Oh, okay.
Same sign.
Wait, why does this time be the same though?
Because if the second sign is plus, they both follow the first. You can do quadratic formula for that.
Oh.
I would definitely do quadratic formula for that over completing the square, because if I complete the square here, I would have to divide everything by 2 first. Then I'm going to have x squared minus 9 over 2 plus 5 over 2, and I'm going to get into some sticky fractions as I start working through. Cannot be factored. All right, so here's one answer. This actually serves as 2 answers, because if you have 3 times x, that means either x is 0 or x is 0, so it gives you their solution twice. It's just a repeated solution. Here, I'm going to go ahead and move forward with quadratic formula. Opposite b plus or minus square root
Of -9 squared.
b squared minus 4 times a times c all over 2a.
Wait, how are you doing that?
It can't be factored.
Oh, couldn't do the box. I was wondering why I couldn't do
Because the same sign, it can't be factored.
that.
So now,
You got any suggestions?
stand up. So now I have 9 plus or minus the square root of 81 minus 40
Yeah.
over 4. Square root of 41 over 4. Can you take anything out? Can you split 41 up anyway? No? I don't think so.
That'd be an answer.
That's the answer.
Yeah.
Work your way through. The end game is you take what you start with and you factor it completely. We talked about factoring completely yesterday where you factor, you look at each set of parentheses after you factor and you see if you can factor it some more. Madison, are you cold? Once it's factored completely, that's the point when you start setting the parentheses to 0. So this was factored completely because it can't factor anymore. I set it to 0 and I have to think about how can I solve a quadratic if I can't factor. Yes, no, maybe so, what we think?
Yeah.
An extra